Most people struggle with understanding the basic design principles in software development. Today, I will do my best to explain them to you in a way that you will understand. But before we start, one thing you need to remember is that these principles are only guidelines for programmers, and you should never just implement them blindly without stopping to think if they're fit for your project or problem. Let's start with the most popular ones, which are the solid principles. So we have single responsibility principle, open close principle, list of substitution principle, interface segregation principle, and also dependency inversion principle. Okay, single responsibility principle states that a class should have only one reason to change. That means that every class in your system should only have one job or purpose. You don't create, for example, a player class that has that is responsible for movement, player stats, player inventory, and so on, but you rather have a separate classes that are each responsible for the different parts of the system. For example, we can implement it like this. So we have some player inventory with the list of items and methods to interact with this list. Also separate player movement and player stats. And this maybe you should be like a class that has a reference to these other classes that combines this functionality into one facade, right? Okay, so we have also open-close principle that states that software entities, so classes, modules, functions, and so on, should be open for extensions but closed for modification. And in English, that means that you should be able to extend functionality of a class without modifying it. A simple example I'm going to show you is we have, for example, this payment processor that gets the reference of the payment method interface. And basically, we can create how many different payment methods we want without modifying the original payment processor. And we can, for example, add a credit card payment, PayPal payment, and so on, without having to, as I said, modify the original class. So we can extend its functionality indefinitely, but we don't need to modify it to do so. Okay, next is the Liskov substitution principle. And this basically means that it states that derivative or child classes must be substitutable for the base parent class, which is a very weird way to say that. Basically, a child class should be able to be used everywhere that the parent class is able to be used. So, for example, this is a very simple example. We have like a list of animals. We have an animal class. We have a cat that extends this class. And for example, we want to print every animal and the sound they make. And we can use cat or animal interchangeably, and there is no problem to do so. Okay. Next, we have the dependency inversion principle. We have interface segregation principle. And this basically applies to interfaces instead of classes, and means do not force any client to implement an interface which is irrelevant to them. And I think it's self-explanatory. Don't put interfaces of classes that don't need the specific functionality that the interface would force them to implement. And the last one is the dependency inversion principle. And that states that high-level modules should not depend on low-level modules. And both of them should only depend on abstractions. That simply means that classes should only depend on abstractions like interfaces or abstract classes rather than concrete implementations, which allow for more flexible and decoupled code, making it easier to change implementations without affecting the other parts of the code base. And this connects perfectly with the previous open-close principle. We depend on the interface instead of some concrete implementation, and we can, for example, change different implementations for the payment processor without having to modify it or depend on the exact implementation. Next, we have the keys principle. So the keep it simple, stupid. Basically, you should make your software as simple as possible. Don't avenge. Sorry, I need to get a drink. Don't over-engineer things. You don't need to be over-engineered. Keys will improve the clarity by making simple designs that are easy to understand and maintain. It will also improve the efficiency of your solutions because they will require fewer resources. The usability and user experience will also be better, and the code will be more flexible because it will be just simpler. And also risk reduction of like bugs and so on will also be uh, improved. KISS principle encourages a pragmatic approach to design and development and makes your code more maintainable, debug friendly, scalable, performant with reduced technical debt. Yagni, you aren't gonna need it. It is also closely related to the KISS principle, and both of these principles encourage developers to focus on delivering the simplest solutions that meet the current requirements rather than focusing on anticipating the potential future needs of the project. So why is Yagni important? It keeps the software development focused and efficient on the implementing features that are necessary. Developers, so you can avoid wasting time and resources on unnecessary functionality, which can lead to faster development times, reduced complexity, and more maintainable code base. So how to use Yagni in your code? You can follow this diagram. So get the necessary requirements, discuss them with your team, or if you are working alone, just like think about it. Analyze a simple plan for the solution, refuse it if it does not fit your solution, and also keep a record of your progress. But I personally didn't do it, so I only put it here because that's like it was like the part of the I would say part of the definition of this principle. Next, dry. So don't repeat yourself. This also encourages developers to avoid duplicate code in your system. The main idea is to reduce redundant code and also promote efficiency by ensuring that a piece of logic only exists in one place in your code. So you try to create reusable components, functions, and models that can be used in different parts of the system rather than writing the same logic in multiple places. The dry principle is related to the concept of modular programming and the single responsibility principle, which we talked about earlier in this video. To implement the dry principle, create functions and methods when you detect logic that is repeating in more than, let's say, two places. Use classes in more complex scenarios and extract constants or configurations. Separation of concerns is a fundamental principle in software engineering. Separation means that you isolate different concerns within a system and reduce interdependence between different parts of this system. And concern is, in this context, a specific aspect or functionality, a behavior or responsibility within a system. This is, of course, very similar to the single responsibility principle that we started the video with. And you can implement the separation of concerns by using the single responsibility principle, by also using a clear and descriptive naming of functions, classes, and models, and by encapsulating logic and keeping unrelated concerns separate. By avoiding side effects, so functionality that by also avoiding side effects, so functions avoid modifying state that is outside of the scope of the function, and by modularizing your code and using composition. I will explain composition later in this video. Principle of least astonishment, or also known as the principle of least surprise. Principle of least astonishment states that the system should behave in a way that the most users will expect it to behave. Or in code, that means that every class, method, module, and so on should have the functionality that is not surprising to the user of that code. For example, if a function that is named clamp, it should clamp numerical values in some range. Not, for example, print the word clamp on the console or send email to the users with the value clamp. Okay. Composition over inheritance. So we should focus on favoring composition over inheritance. Everybody watching this video probably knows what the inheritance is. It's when one class is extending the functionality of other class with its functionality. For example, person that has fields like name and surname can be extended by employee that add additional fields like salary and date of employment. Composition, on the other hand, is achieved by creating a class that includes references to instances of other classes. For example, a person, I'm going to show you that in code, person can, for example, have a reference to address, and this way we make a connection between these two classes instead of having some like inheritance here. Composition reduces the risk because changes in one class do not directly impact other classes. It also allows for better testability and makes it easier to test individual components by substitution with mock objects if needed. Convention over configuration or coding by convention. This design principle attempts to decrease the number of decisions that developer using a framework or library is required to make without decreasing flexibility and by don't violating the dry principle. This praise essentially means that developer only needs to specify unconventional aspects of an application. For example, if a class is called user, the corresponding table in the database should also be called user by default. We can find this principle in many modern frameworks. For example, in Spring Boot, Angular, we have set a project structure that is the same in every application. In pom.xml, we have metadata and dependencies of the project. In source main Java, we have all the Java code. In resources, we have all the resources, configs, and static HTML, for example. In short, when creating libraries or frameworks, we should only make the user of this library or framework specify the things that are unique for the application. And don't think about stuff that is repeatable. If you want to learn more about Java and Spring Boot ecosystem, I invite you to my private community. Check out the top link in the description. Here is the next video, YouTube things you should watch. Until next time, create some amazing applications.